Hello, welcome to this Conservation Applied Research and Development webinar. My name is Scott Hackle. Want to start with a brief introduction to our webinar presenters. Again, my name is Scott Hackle. I'm Principal and Director of Engineering at Seventh Wave. I consult with architects and engineers on energy efficient buildings, both their design and their systems. I conduct applied research on technologies and processes through both field monitoring and extensive energy modeling. We also have Ken Potts here today from Mayo Clinic. He is a project manager. He's part of a team that manages more than 13 million square feet of healthcare facilities, both new construction and ongoing operations. In addition to delivering individual projects in support of Mayo's mission, Ken oversees an annual program to advance energy efficiency through improvements to exterior envelope and building automation systems. Then finally, we have Patrick Smith. He's a research fellow with the Center for Sustainable Building Research at the University of Minnesota. His research experience in sustainable building includes policy development, utility auditing and performance evaluation, metrics, benchmarking, and implementation of life cycle analysis in green building. He's currently involved in program development and assistance in the B3 and SB 2030 programs, which is what he'll be talking about today, and piloting improved building delivery methods to enhance energy efficiency. Thanks, Ken and Patrick, for coming today to present with me. Just a few basic ground rules for the webinars today. All attendees will be in listen only mode, so you won't be able to speak, but you can type questions into the question box and we will be answering those at the end. The webinar will be recorded, so you can go ahead and listen to it again later if there's something you missed or if you have to leave early. Just a few words about the Minnesota Applied Research and Development Fund before we get started with the webinar. The fund was established in 2007. The purpose is to help Minnesota utilities achieve their energy savings goals by identifying new technologies and strategies and by improving the effectiveness of utility conservation programs. And finally, also by documenting CO2 reduction goals from such programs. A utility may reach its energy savings goal directly through conservation improvement programs, or SIPs, which we'll be talking about today, or indirectly through energy codes, appliance standards, behavior, and other types of programs. The CARD program spending is shown here on this slide. Since legislation was enacted, the CARD program has been able to fund 22 different RFPs. It's received nearly over 380 proposals to those RFPs, and it's funded 92 research projects, representing over $21 million in research. And as you can see by the pie chart, projects are funded in all building sectors in a variety of different types of projects. The subject of today's webinar is the commercial sector, and it reports on an initiative in Minnesota that we've tested known as performance-based procurement, which allows building owners to specify energy performance targets in new construction and major renovations. That allows them to select construction teams based on their ability to meet those targets and then hold them to those targets throughout the process. With that, I'm going to jump into the content for today's webinar. As we go along, please type questions into the question box, and we'll certainly get to those at the end. So I wanted to start with just a little bit of context. Minnesota's building community has been a leader in focusing on energy performance of new buildings and major retrofits for some time. Our community recognizes these as important opportunities to impact energy performance for a long time. You know, buildings last 50 to 100 or more years. But there's evidence of the mainstream green building movement potentially plateauing a little bit in terms of its ability to continually increase performance and sustainability. On the utility conservation improvement program side, in the new construction sector, savings is beginning to be eroded by ever advancing codes. You know, Minnesota fairly recently adopted a new energy code. They'll continue to do so, and those eat into the savings in new construction programs. So for both of these reasons and some others, it's worth considering a fresh approach to how we attack new construction energy performance. So what could such a fresh approach look like? Well, here's a few thoughts that we had as a group. What if we started with the owner and focused primarily on the owner's goals and how those align with energy performance? as opposed to waiting until a design team is selected and focusing on what that design team is doing, and acting more at the lower end of the project org chart, as is shown here. And what if we overcame the dual model system that has been traditionally used, where a significant amount of effort is focused on a theoretical baseline and how our building compares to that, and instead shifted to all of our effort focused on analyzing the actual outcome of the building, what the actual utility bills would end up being, and modeling with a focus on that. And what if the energy budget for a project were set at the same time that the capital budget was set, and that the two were held up together at the same level? And finally, what if the design and construction teams were then given freedom to approach that energy budget however they saw most effective? On the one hand, potentially using improved design, but also able to trade off things like better commissioning or startup or operator training in place of more expensive systems. So we undertook a project to test those hypotheses. Those were really hypotheses throughout our project, through a mechanism that we're calling performance-based procurement, which I'll describe in just a minute. And it turns out there's already a program that works with public buildings in Minnesota that utilizes a lot of the elements of performance-based procurement, and that's the SB 2030 program, and SB 2030 Energy Standard program, and that's what Pat's here to talk about today. So we observed this approach through both SB 2030 and other projects outside of SB 2030. We'll talk in the middle of the webinar today a little bit about that pilot study and the projects we observed and the outcomes we observed. And then we're going to finish up by talking about this from the context of the programs themselves, how you can programmatize this approach in a utility program or another type of program. So first I want to start out by sort of defining performance-based procurement. I'm going to do so fairly simply. Performance-based procurement at its heart is creating an energy target, a performance target for the building very early in the process, and then focusing all aspects of that process, from planning to design to construction to startup to operations, on achieving that single target. Now, the idea of having a single metric that we focus on for the performance of a building may seem oversimplified. A building is an extremely complex thing that has a lot of different actors, some who focus on energy all the time, others who never think about energy. How can we boil this down to one metric? Well, I would point to the example of the miles per gallon in the automotive industry. A lot of different people, from those who buy cars to those who sell cars to those who build and design cars, have to focus on the energy efficiency of an automobile, but very few of them need to understand how an engine works or what makes a car aerodynamic or fuel efficient. They're all able to use this simple metric of miles per gallon to understand where a car may fit in terms of their goals. So how does this look in the context of a building? Well, let me give you another example that'll kind of bridge us over to the buildings world. So this is kind of a simple Venn diagram in its whole, showing all of the new buildings or major retrofits that may occur. Some portion of those projects would be considered sustainable, or maybe certified by a third-party rating system, or maybe considered high performance. There's a lot of different sort of terms we could use for buildings that don't use a lot of energy. And that's shown in the yellow portion of this diagram. Some small subset of that, it's probably smaller than what is represented by this conceptual diagram, are able to achieve zero energy. Now, I think there are two things that are actually impressive or stand out about buildings that achieve zero energy. The first is obvious. They don't use any net energy, and that in of itself is a laudable goal. But another element of these zero energy building projects is that they all are designed and built and operated with a focus on a single energy target. Now that target happens to be 0. What happens if we simply expand out that population of buildings to capture those that for budget reasons or other reasons can't get to 0? Why can't we do the same type of approach but shoot for 10 or 20? And in this case, when I refer to 10 and 20, of course, I'm talking about the EUI of the building, the energy use intensity or energy use index, depending on your terminology. And we'll be describing different building projects that we observed in relation to their energy performance target using that EUI metric. But our sort of argument here is that a performance target can be a very valuable component to a procurement process, whether you're going for 0, 10, 20, 40, or 150. So now let's think about how this performance target approach works from the standpoint of a program. In this case, a utility program or conservation improvement program, if we're thinking about it in the state of Minnesota context. So here I have a diagram showing the entire design process from planning through design and construction into operations. And we show in the orange the amount of effort that we put into making that building energy efficient in current practice. In most of the projects I've been associated with, we really ramp up our effort and focus during design. As design progresses, we do more energy modeling, we do more consulting, more review. We're trying to push, with performance-based procurement, we're trying to push that effort to much earlier in the process. So we're putting effort in the planning phase and then in the RFP phase to establish a target for the building using benchmarking, potentially conceptual modeling, and write that into the RFP and then into the contracts so that we can kind of step away and put in less effort during design and construction and operations. And from a program standpoint, at that point, after we have established a performance target and passed that on to our design and construction team, most of what we're doing is just reviewing submissions that the design team's making, showing that they're capable of achieving that target. And then in the operations phase, showing that they have met the target. So it really becomes a much lower effort review process from the program's point of view. And then of course there is an incentive mechanism in most programs, and this would be no different, that we would incorporate towards the end. And there's a couple different ways to do that incentive mechanism, which I won't dive into right now. Now I want to dive into a few of those steps, though, mainly the ones right in the beginning of the process, in just a little bit more detail to describe how we implemented those steps in the pilot projects. So the first step, of course, is setting the target itself. And this is perhaps one of the most important steps. And for the most part, we like to use because this is an actual real energy performance metric for the building, we like to use actual performance data to help us set the target. So we'll generate a plot like the one shown here. This is something that we generated when we were helping Aon, which is an affordable housing developer in Minnesota, develop a project. We show different types of data. So here in dark orange, we have Aon's building stock of similar buildings to the one that we were talking about with them. We also in green show similar buildings that have been benchmarked throughout Minnesota that may not be Aon buildings. And then there's also one sort of best practice building called the Rose, incidentally. Some of you may have heard of it. That is also an Aon project that they point to as sort of one of the best they've achieved. And we're able to use this to determine, do we want to set the target as the best building that Aon has designed and operated, or do we want to make it average or somewhere in between? This allows us some flexibility to choose an appropriate target. Then we want to integrate that target into the RFP and contract documents. This is really a key element. You can't just, performance-based procurement would not work nearly as well if you simply selected that target and then held it up as a suggestion. You really want to include it in the RFP up front so that everybody who bids on this job knows what they're getting into, both design and construction. One element that we like to include is potentially doing a couple tiers. So you have your mission critical targets, which are everything that a team must absolutely achieve. You can also include some highly desirable targets, which might allow you to find a team that's willing to commit to a slightly higher goal even in order to win the work. Just something to consider. That's not an absolute requirement of the process. Incidentally, the RFP documents that we developed as part of this project, we have made generic and posted as an appendix to our final report. So if you go online, our final report's not up there yet, should be up in a week or two on Commerce's website. You can get the RFP language and use it on one of your projects. And then finally, I would mention that a very important early step is to get in and do some energy analysis. And this is, you know, the energy analysis that you do during design is also potentially important, but when you've set a performance target, it's useful to also do some early just shoebox modeling for a couple reasons. One, to kind of determine, as I'm showing here, where the biggest bang for the buck is. Is it in lighting? Is it in the envelope? Is it in HVAC? But also potentially to help you set your target. If you have sort of a unique building type without a lot of benchmark data, the concept model can help you actually choose what your target should be, which incidentally is what the SB 2030 program uses in the public building sector to choose its targets, which is a good segue into over to Pat, who's now going to tell us about the SB 2030 program and their approach to
where we are and some of the reasons why we were interested in looking at performance-based procurement for potentially improvement to the SB 2030 energy standard, the SB 2030 program in Minnesota. So SB 2030 was created in 2007 alongside the conservation program and mandates increasingly stringent energy targets for performance for state-funded projects and requires the evaluation of this energy consumption both in design and through 10 years of operation of the project. So essentially what we do is set an energy target in design that the project is then required to meet in operation. And this is implemented as the energy target, as the energy requirement for the B3 guidelines program, which state-funded projects need to be projects that are funded through state bond funding, which includes a lot of state buildings, but also includes some private buildings that come and access state funds. The program establishes a baseline based on average building stock in 2003, and it requires targets that yield increasingly larger savings from that baseline over time. So we began this program with a 60% reduction between 2010 and 2015, a 70% reduction, which is what we're in right now, between 2015 and 2019, and that ratcheting down every 5 years until 2030, when net zero energy performance is required for new construction projects. After the building is occupied, annual energy consumption is tracked through our online benchmarking and project tracking database to ensure that the project continues to meet its SB 2030 targets. So this is really, we're doing a test and design. We're also doing a continual test and operation just to make sure that the projects that are going through the program continue to achieve these savings. And so that brings the question, how do we set this target? And to do that, we developed, as part of this online tracking, the online tracking tools that we use, what we call the Energy Standard tool. This allows project teams to input basic building program data and to create an appropriate energy, an EUI for that building, so an energy target in kBTUs per square foot, energy use per square foot, which we call the Energy Standard. Listed here are just what we view as the needs of that tool. So it needs to reflect the building performance program parameters. It needs to be able to be run during pre-design. It needs to be able to accommodate that design as things do shift in, between pre-design and kind of final construction documents. And even in operation, if the program changes during the operation of the building, we want to be able to accommodate that kind of shift. I'm going to show quickly a snapshot of that tool and then some of the things we pick up for that standard setting, for that energy budget development. So our goal here is to streamline the inputs. They only at the pre-design phase need to know the overall program breakdown of the building. And additionally, one thing that we've been able to implement in the last couple of years is some ability of the tool to actually evaluate the impact of energy conservation measures. So there's one spot where the building designers can look at for their energy standard setting, and also the evaluation of strategies that they're using to meet that energy standard. So the goal for this is really streamlining, but streamlining to the point where we can maintain accuracy, but limit the barriers to inputting that information really early in the design process. Because as Scott mentioned, really pushing up front those big decision points early in the design allows a broader array of different opportunities to be accessed. I'm gonna hop over and just talk a little bit about the structure of the pilot study that the CARD grant funded, and with how we set out to test this process and how it works across a few pilots. So the project was formed around case studies of pilot projects. So we used a case study methodology. We did this to allow multiple sources of data to be incorporated and to really test this performance-based procurement approach in two primary market channels: utility SIP programs for major building owners and developers, to basically look for best practices. Our goal was to find at least 2 design projects to be public buildings involved in SB 2030. So there was already an energy target baked into that with the target setting mechanism that I just went over, and at least 2 projects that would be private buildings. Ideal projects that we looked at bringing on board would be in the pre-design or early in the schematic design, and would have completed design development within the 18-month period of this study. So we didn't have the ability to capture these all the way through operations, but we wanted to take a look, what does this look like during the design process, so that we can get an idea for what the opportunities are and what the barriers to implementation are. We also interviewed program stakeholders, including implementers, energy modelers, and some participants, again, to capture this idea of opportunities and potential barriers, and feedback on our approach to the process. So in terms of stakeholder feedback, there'll be more detailed assessment of this in our final report. This is a snapshot of some of what we heard as we did those interviews. Some responses are shown here. The initial experience indicates that there is room to improve coordination and interaction between Excel's new construction program, that's the EDA program, and SB 2030, because that's many of the design teams that we interviewed were being required to meet SB 2030 and then utilize that EDA program to do so. And because they were kind of 2 forces that acted on their designs, there was some confusion about if the overall goals were aligned, but the somewhat different mechanisms to do so. As Scott mentioned earlier, the advancement of codes was noted in the stakeholder feedback as pushing on the ability of programs to achieve savings. Most owners that we discussed this with welcomed and appreciated the additional support that can be provided by any of these program elements, SB 2030, that the Excel's new construction program, or performance-based procurement, as long as we can figure out how to align with their design practice, how to integrate this with what they're already doing. We had one owner state that they only had so much internal capital to integrate new sustainability initiatives with, so it was really important that they understand the benefits and that of this program of performance-based procurement, and that we made it as straightforward as possible. One potential barrier that we saw was the existing development practices, whether that means typical design bid build, or simply just not being able to change protocol in the short time that we had to interact with projects. There's a potential area that's going to be a little bit sticky to implement this with. So I'm going to back up one. Another noted barrier was energy modeling. Software tools with rapid feedback have not previously been readily available. That's changing a bit now, but that was seen as potentially making more difficult the really early design decisions around those models if you're doing a shoebox model early in the either pre-design or early schematic design phases. And as some of the energy modeling has existed at the utility program, in the utility program realm previously, it may be a new activity to have design and construction teams complete their own energy modeling. So that may be a bit new. We discussed this program with energy modelers specifically, and have a few comments summarized here. We ended up talking to about, to believe, 10 energy modelers. They noted that they most often got first involved during schematic design, although a few were involved earlier with more of this shoebox modeling in the pre-design or early schematic design. They viewed their primary influence as being the determination of the mechanical system of the building. And even though that energy charrettes, they viewed those as being really helpful to have projects save more energy, they only occur about 10 or 20% of the time. Their ideal process was when the owners were more sophisticated, or when they had more specific performance and sustainability goals in mind. So that bolsters one of the main program elements of performance-based procurement, which is setting that energy target and keeping the focus on that energy target. Most projects in the cohort that we looked at relied heavily on the white group, which is a large energy modeling presence in Minnesota, as part of their Excel new construction program. Additionally, some stakeholders expressed that the energy modeling community is not strong, is strong, but not large. So we are a little bit behind some other regions in the country. Energy model tools are improving, which does assist that early energy modeling process, but still requires experienced energy modelers to work with, interpret the results, and work within the limitations of those tools, particularly when you have when you frame the discussion around achieving high energy performance targets, such as SB 2030.
Thanks a lot, Pat. So that describes sort of the backdrop work that we did for our project. Now we want to shift to describing some of the specific projects that we observed. In the end, as Pat mentioned, we were trying to observe at least 4. We actually observed 9 projects, but at varying points in that performance-based procurement process across the 9 different projects. So some we were able to see and observe in design, some prior to design, some in operations, but having a limited 18-month period to our pilot, there wasn't a single project or 2 that we were able to observe through the entire process, but we were still able to come away with some really nice conclusions. And we're gonna start in a minute by diving into one of those in significant depth. Ken from Mayo will cover that project. I wanted to pause though for a second and just remind viewers to go ahead and ask us some questions as things are going along. Anything you want a little bit more clarification on, or something you're wondering, definitely type it into the question box and we'll handle questions at the end. And before I pass it on to Ken, I did just want to give a quick overview of some of the owners' perspectives as they progressed through this project. And you might see some of these elements come out in Ken's description of Mayo's experience. So on the one hand, we did have some concerns from owners who were considering or actually entering this process. Of course, top of mind for everybody is budgets, both their operating budget, which is actually a potential opportunity for the program to improve the operating budget of buildings, but also capital budget of the project. Procurement schedule is always an issue. It was very clear when we are implementing this that we cannot have an impact on the schedule of the building in any way. And then we recognize that there are competing organizational goals, and this is potentially one more goal to throw in the mix. But on the flip side, there were also some opportunities that were recognized. On the one hand, some owners, and I think you'll hear this from Mayo, recognize there is an opportunity here to reduce uncertainty in the building performance by including a performance target in all aspects of the process. There's also the opportunity to use this process, as I described early on with goal setting at the RFP phase. There's the opportunity to align team goals and get everybody on the same page through a slightly more rigorous goal setting exercise. And then finally, in the end, I think most owners recognize that there was not a negative budget impact to utilizing performance-based procurement. And of course, that depends on where you set your target. If an owner wants a really aggressive energy performance, that may at times cost a bit more. But if this is implemented correctly in the RFP, that'll of course come out before you hire the design and construction team. So with that sort of general set of feedback, now we want to narrow down and focus on just one of our projects, which Ken Potts will now tell you about.
Thank you, Scott. Mayo is just starting the construction phase of this project, which I'd like to tell you a little bit about how we use the process, and so far to great effect. I'd like to take just a minute to introduce Mayo and some of the things we're doing by way of standard practices, and then dive into the details of our new project. So we're an academic medical center with a presence in Jacksonville, Florida, in Phoenix, Arizona, and Rochester, Minnesota is our home base, where we operate over 2,000 licensed beds, have 115 operating rooms, and a host of research and education activities. Rochester is really our home base. On the topic of environmental stewardship, that is one of Mayo Clinic's core values. And we definitely have strategies that take us through our design, construction, and operations phases of projects in our physical plant. And we also extend that to purchasing and waste management practices. On the energy conservation front, in 2010, Mayo Clinic committed to the Clinton Global Initiative to reduce our 2010 baseline energy use by 20% by the year 2020. And the chart on the bottom half of this slide shows that based on the end of last year's measurements, we were down 16% from that baseline. So we're well on our way to hitting that goal. Although certainly we've taken care of what we call the low-hanging fruit on the operational side, and really needed to find some new tools to bring this into the realm of new construction projects. And so that's where the Generose building expansion provided a great opportunity to try out the performance-based procurement process. This is a picture of the existing Generose building. It's about 25 years old since it was first constructed, and our plan is to add 3 stories on top of an existing 3 stories of this building. It's roughly a $60 million project, and the programmatic elements of it are psychiatric care and also some physical rehabilitation. So in terms of getting started, first we had to establish our goal, and we measured what our trending data told us about the existing operations and came up with an energy use intensity for this existing building of 153 kBTUs per square foot. So we set some goals for the expansion, and we built those into the RFP we issued for both design teams and construction teams. And this is one of the early renderings of this building. And as I show you a couple of different images, you'll note some subtle changes to the exterior envelope and the degree of curtain wall, as that became a key area in which we were going to either hit or miss our targets. Basically, we were given a footprint, we were given an existing site orientation and even structural capacity, which put some restrictions on us. And then perhaps most importantly, our source energy was certainly not going to change. And Mayo uses cogeneration for steam and electricity for natural gas throughout the bulk of our Rochester campus. So that's certainly what we were going to extend here. So what was key to pulling this off was determining that EUI target early, building it into the RFP for the design team, and having that added into the usual mix of needing to hit a construction budget, a construction schedule, an aesthetic expectation. Now we've added performance, which helped us with some of the decision-making along the line. And one of the key elements listed in the RFP was that contractually, we're going to hold our design team to a 1-year measurement. Once we cut the ribbon and occupy the building, we're retaining 2% of their construction fee until we prove after 12 months that we are indeed hitting that goal. So what we set for ourselves was 122 kBTUs per square foot as our target goal. And as I mentioned, we started with an existing building operating at 153. We also got some help from Seventh Wave to look at industry benchmarks for both inpatient and outpatient buildings nationally. And that's how, by kind of mixing those variables together, we came up with this goal of 122, and that was published in the RFP. With the design approach, we've got our variables in our climate zone 6A that we're based in to work with. And again, showing down below here in some of the 3D models, you see a couple of different facade approaches. We did look at all manner of different strategies, and at each point having a design and construction team working together from the start, we were able to measure both that performance as well as do a check on our budget. So for instance, we looked at using chilled beams in the building and investing in that upfront cost by saving in the floor-to-floor height of a building that did not pan out. Another thing we looked at on the glazing system was using a triple glazed system, and I'll walk you through a little bit of that in terms of managing those facade loads. So this chart here, I'll have a couple of columns that I'll add to this initial one. It stacks up the capital cost of the exterior envelope, so roof and walls at $8.3 million, and the resulting operational cost for 1 year using a standard curtain wall system. And the feedback we got, we certainly had our costs in there. The energy use intensity of 138, however, was not going to hit our target goal. So the next step was to take a look at some additional first cost expenditure to triple glaze curtain wall, adding about $500,000 and realizing some payback in the operational costs. But if you're running the numbers here, you'll realize it's about a 20-year payback, which was not really acceptable in terms of realizing those operational efficiencies. So we challenged the design team to go back and try another option. And what they looked at then was a combination of curtain wall and a rain screen system with punched windows, in effect, an insulated metal panel system. And that turned out to really be the winning strategy here, because we saved both on the initial capital costs by spending $7.5 million there compared to over $8 million for the other strategies, and additionally saved on the operational cost just by getting a higher performing envelope overall. So that gave us this aesthetic for a design solution. This is a view of the north facade where we, in addition to just picking that facade assembly material, we looked hard at the amount of vision panel and spandrel panel and of course glazing types here, and programmatically decided the best solution was to put that curtain wall appearance on the north facade, and then following around on the other facades of the building, the combination of punched windows where we have inpatient rooms and insulated metal panels. And I've got the proportions broken down here to see that that really made a big difference, and it was definitely the result of many iterations of a good process that led us to this point. So that construction, as I said, our tower crane will be going up in the next couple of weeks. We expect to have occupancy early in 2019, and we're headed toward an energy use intensity of actually closer to 110, well below the 122 goal we set ourselves out for. So we're very much looking forward to occupying this building and testing the energy results.
Thanks, Ken. Yeah, it's going to be exciting to see how that one pans out through construction. I'm looking forward to following it and continuing to work with you guys. Now I just wanted to sort of expand back. So we narrowed down for a bit, focused on one project, but again, we've been following several, and a number of those got through to the point of having an established design with an estimated EUI. And there's a lot of information on this chart, and you can download the slides whenever you'd like using the go-to panel. get so that you have all this information for your records. But what I really wanted to focus on was the estimated savings in the third column. And this is savings against a baseline, not savings between those first two columns. And we're seeing savings of between 30 and 60%. And again, the goal of performance-based procurement is not to compare to a baseline. In fact, we're kind of trying to get away from that. But in terms of understanding how this compares to traditional practices where percent savings is such a common metric, we wanted to include it here. So we're seeing some strong energy savings. Of course, to understand the cost effectiveness of this approach, we also need to consider cost. And Ken gave us one data point for cost, which was great. We have been able to get some other data points for cost. Cost in this pilot, cost turned out to be harder to obtain than we had planned. So we have a limited amount of cost data, and it wasn't ready for compilation in this webinar, but we hope to include it in the final version of the report, which again, hopefully you'll be able to download in a few weeks. So stay tuned for that. So that covers some of the specific outcomes that we had across some of our buildings. Again, certainly download the final report, and there's a much more in-depth dive into all 9 of the projects that we touched on, so you can learn a lot more. For now, with the last 10 minutes or so of our 10 or 15 minutes of our webinar, we wanted to shift over to talking about the opportunities that we saw to integrate this into a program. Because in the end, our pilot was able to affect a handful of projects, but what we'd like to see happen in Minnesota is potentially for this to be, for elements of this to be embedded into programs so that it can live on and affect many buildings. So let's cover just a few of the opportunities that we saw for programs. First, starting a little bit from the angle of utility-centric programs, and then we'll shift back to discussing SB 2030. So utility programs have a significant opportunity in engaging more with the owner. One thing we noticed in all of our projects was just some excellent conversations and back and forth on approach with each of the owners that we were involved with. This allowed us to align their values with the performance goals right up front, so that when we got into difficult decision-making time on things like design elements or the M&V plan, we had complete buy-in. It also facilitates some discussion within the owner team. So a good example is with those Aon developments. They're used to considering energy performance when they're designing new developments, but the establishment of an energy target actually led them to bring their operations team in earlier than they normally would and consider, well, what is a good energy target? What are you seeing on the other buildings we're operating? Just got a lot more conversations started within the owner team itself. And then finally, there's an opportunity here to improve customer satisfaction with your program. A lot of new construction focused programs end up spending a lot more time with the design team than they do with the owner, just because of the way they're set up, and it works for a number of things. But one thing it does not do is get you a lot of time with those owners, with those utility customers, and this program would potentially increase that amount of interaction. But I think potentially the biggest opportunity here is a shift in focus to real performance of the building, as opposed to a theoretical comparison to a baseline. And to demonstrate that, I just drew up a simple little graphic here showing building performance, a range of building performances from at the top, just an average building, to a very low energy building at the bottom. And this is just conceptual, there's no specific scale. And let's look at the different ways that we can push a building from being just average to being a low energy building. The key, the main area that we all think about in trying to procure or build or design a high performing building is the design stage. And typical energy efficiency programs focus heavily on this stage. In fact, there's one subset of this stage that most focus on, which is regulated improvements. So those are things we can improve in design that are regulated by code or by a standard, so that we have, a baseline to hang our hat on. So that's one sliver that current programs are capable of sort of impacting. But there are others in the design stage alone, like unregulated components of the building, like plug loads and infiltration, or code compliance that programs can't really go after right now. And then after the design stage, there's a whole host of other stages like the quality of the installation, commissioning, and then into operations, the behavior of the occupants, and O&M. When you shift to focusing on the actual performance of the building in the first 12 months, 18 months, and that is your metric, all of these stages become fair game. We can get squeeze just as much savings out of a building by putting more effort into training that O&M staff potentially than we can with some of our design improvements. So with performance-based procurement, we open ourselves up to a wider range of opportunities. And then finally, we could potentially have some more real influence on designers. Once you set up a very concrete performance goal at the beginning of the process and get everybody aligned to it, you'll have designers responding to that goal because it's in their contract, as Ken described with the EUI and how it impacted the decision of the facade in the Generose project. Now, it is important that you allow flexibility to your designers. So you don't want to tell them, oh, you have to get to the EUI target with a better glazing. No, give them the option to do it with better glazing or lower window wall ratio or more insulation or any other avenue. As long as we're going to put this constraint on the team, we also then need to back away and give them flexibility. Now, these opportunities do lead to some challenges. We recognize that now we're working with owners. It's a slightly more diffuse group than design teams. Timing is an issue. You do need to get involved early in order to have this impact. And then we might need to change the utility evaluation framework a little bit to make this work. We believe those challenges can be overcome, at least for the most part. Identifying the right customer is very important to get us past the first two challenges. And connecting with customers early can be done through a variety of channels. We felt it useful to leverage utility account managers as well as local channels like plan commissions. Also offering bonuses like energy charrettes and bonus incentive, which we're actually doing in some other territories through utilities, can be helpful. And in the interest of time, I'm going to kind of breeze through this slide. Like I said, we didn't collect a lot of cost data, but we did create some metrics for what would make a cost-effective program. And we feel if utilities can get performance-based procurement in line with these costs and savings, you'll have a successful program. With that, we want to shift back to talking about the same sort of opportunities, but for the public sector SB 2030 focused program.
Thanks, Scott. So again, so this is looking at how we can improve SB 2030, given that we already have in place energy target setting mechanism and then the requirement for these projects to hit that in design and operations. I just showed here a quick roll-up of some SB 2030 projects and looking at the first few years of operations. And I brought this up just to show that as there is variability in how these projects operate during the first few years of operation, does point to an opportunity to improve that performance using operational, using essentially the operations team to continue to target that level of savings that was designed into the building. It's actually achieving what the designers intended to hit. Additionally, SB 2030 it does share a lot of the performance-based procurement elements, primarily the use of a EUI as an energy target. Though some that could be improved include, and this is somewhat noted through our interactions with the stakeholders that we interviewed with, were getting more and earlier interaction and engagement with the building owners specifically, and improvement of coordination and assistance through the building operations. So this is both looking at the very front end of the design project and the very tail end, so the owner group and the operations group. We've begun to make some of these changes already, even while we're doing this pilot project. Over the summer, we launched B3 Guidelines version 3.0, which SB 2030 is the energy target standard of. and we included a updated set of owner's project requirements, things that are required for that OPR document, which we put a very bright line around setting that energy target in during that really early OPR development phase. Some projects in SB 2030 we've noted are somewhat less owner-driven and are led more by the design team. And depending on the design team, these may or may not be considering energy to be primary priority. So if they aren't considering this a primary priority, that pushes the energy requirements to later in the design process, and that results in some projects having to go back and do some amount of redesign, when if this was just looked at earlier in the process, that would have been more streamlined. We also think that formalizing and front-loading the review process would also streamline and improve compliance. So getting projects in and have the ability for us to do our review in a timely manner. Additional opportunities, and from observing these pilot projects, we found that an owner's understanding of the path through SB 2030 isn't necessarily as important as their commitment to achieving the goal. So it's really about communicating the goal to the owner group. That's the primary need we see. Also, the program should benefit from a simpler, clearer communication of the mandatory nature of SB 2030 for these projects that are receiving state funds, and with specific guidance to owners about the importance of early goal setting, which should result in more committed owners engaged earlier and with a more streamlined design process. And so for linking performance-based procurement and SB 2030, as I mentioned, we already have the energy target baked into our program, but there is room to shape outcomes, especially in owner motivation, in our efforts of enforcement, and in the participation of voluntary projects. So making a streamlined process that voluntary projects can access to be able to achieve high levels of performance. And then taking a long-term view, we think that performance-based procurement in Minnesota may need to have two paths: one, to widely introduce performance-based procurement with an open goal setting, and a second path that would better support SB 2030 as the performance-based procurement goal. I'll hand it back to Scott to go over some context of performance-based procurement and then some conclusions.
Yes, and since we did have a few technical difficulties at the beginning, we are going to go a few minutes past. I only have 3 slides left, so we'll be done with the content, and then we'll do some questions and answers. So we might go about 10 minutes past. Thanks a lot for your patience there at the beginning. To put this in just a little bit of context, I did want to identify the fact that on the code side, there is also a shift towards performance-based or outcome-based approaches. There's already a few cities and jurisdictions that are piloting outcome-based approaches to codes. And so this might be a way for Minnesota or another jurisdiction to kind of stay ahead of the curve on the code side as well, to implement a program that utilized performance basis. There's also a significant movement towards more benchmarking. The map on the right shows the benchmarking ordinances in place around the country, including a couple that are in action in Minnesota. And benchmarking works really, we found that benchmarking worked really well with performance-based procurement in both directions. For starters, it actually allowed us to do a lot of good benchmarking for target setting. I showed that plot with Ann's buildings early on. We got a bunch of that data through the benchmarking ordinances in Minnesota. So that's really useful. On the back end, once a project goes through performance-based procurement, it's going to be collecting just the right amount of data to easily comply with any benchmarking ordinance. So these two really feed off each other. And I think those are both important contexts for how performance-based procurement might work well in a jurisdiction. And finally, just wanted to leave you with a few of the bigger takeaways, at least from my perspective. As we went through this project, we see significant benefit in shifting the focus in both public programs and private programs to real energy performance targets. SB 2030 specifically can and will be improved to both improve compliance and to align more with CIPs, with SIPs. And then we found that when you're connecting with the right owners, there's significant opportunity for improvement in both impact, more energy savings, and influence, real ability to change the outcome of a building. So if there's just a few things you take away, those would be the ones I would take away from this. Before we shift to questions, I did realize there was just one thing that I forgot to say right up at the beginning as we were dealing with some of those technical issues, and that is just to thank Minnesota Department of Commerce and the CARD program for making this project possible. We learned a lot. If you download our report from the Commerce website in a couple weeks when it's available, again, you won't find it up there yet, you'll find a lot of detail, and all that was possible through that CARD grant. And I also wanted to thank the U.S. Department of Energy, who supplied significant matching funds. It was really those two entities working together that made this possible. With that, I do want to jump into questions, and I believe I'll be reading the questions because we're still having an issue with that audio feed, which should be fine. I wanted to start with a question for Ken that I thought was good, and I know he touched on this a little bit, but maybe just a clarification here. What was the delivery method that was used for the Generose project, design, bid, build, etc.? And then could you reiterate kind of how you incentivized or penalized the different element actors on that team to hit the target?
Sure thing. That's a good question and really a critical piece, I think, to pulling this off successfully. So we're using a construction manager at risk delivery system. And what we tried to do from the very beginning was build a good integrated team with a lot of communication channels and regular meetings starting early on. So once we had an architecture and engineering team selected, we immediately set up interviews for the general contractor and actually had a couple A&E team members sit with us and engage in those interviews. As far as carrots and sticks, I did mention a 2% design fee holdback based on successful 12-month results. For the construction team, there is no penalty. And I guess I would say this is Mayo's first time trying this sort of approach with performance-based design. So we're working our way through it, and we've set some standards that we think are pretty reasonable. We don't think that 122 goal was a stretch by any means, and I think that's well demonstrated by the fact that they're expecting to come in more like 110 kBTUs per square foot. And by having that team working together early, we also are doing things like building physical mock-ups, not just for an aesthetic review, but also to be able to look at constructability, and having the general contractor on board early and the CM at risk process also allows for them to bring in select subcontractors early on and make sure that the EUI goal was clearly communicated to all of them. So really everybody's working together through every aspect of this in terms of building this building and making sure it does perform, that assemblies perform as expected, not just individual components.
Thanks, Ken. So we had that question specifically about Mayo. We also got a related question in general. We talked about incentives to hit EUI targets in the RFP, but what happens if they don't hit the target? Who is held responsible? And so it's kind of the same question, but I just wanted to address it generically as well. Because we've now piloted this approach in actually a few different states, not just Minnesota. We have found some success with 3 different sort of approaches. One is a carrot approach where you provide a bonus to the team for hitting the incentive. You can imagine that working in certain scenarios, especially if you've got sort of a stretch goal that that you feel is particularly aggressive. There's also the stick option, often a retainage in somebody's fee. Now, usually we're operating in either a design build or a CM at risk delivery method so that we can use the carrot or the stick with both the design and the construction team together. Design bid build's a little bit more tricky, and we're still actually working out the kinks with that delivery mechanism, to be upfront about that. There's actually a third method, which is kind of what Ken described, which is to base it on relationships and the incentive to get future project work with that owner. This works really well for large owners, public entities, for which the threat of potentially not getting additional projects with that owner is a significant incentive. So we've actually seen all three work successfully.
So Scott, if I could just add on to that briefly, one thing in terms of providing an incentive or a bonus, I think that works well if you know your program very well. In our case, we only had about half of the building programmed and still have shell space for about a third of it as we figure out how to fill it up. So once you bake in this energy use intensity goal into a contract, you don't want to have that number moving as you make programming decisions. So in this case, we just decided it was simpler to go with the stick approach, I guess, for this first time out.
Thanks. Yeah, good clarification. We did have one real specific question for SB 2030, and that is if they're going to continue to use a baseline based on 2003 data now that CBEC's 2012 data is available.
And so just I'll talk a little bit about some of the ways that we operationalize the SB 2030, the architecture SB 2030 idea. In short, we will still continue to use the 2003 baseline. And one of the reasons for that is to hold steady, essentially, the reference case, and then take increasing reductions from that, moving from now to 2030 when we're targeting net zero for new construction projects. Additionally, we don't still reference the CBEC's database. For that, we've actually moved that into a 2003 modeled base building, just simply to accommodate the large number and various space types that buildings funded by Minnesota actually have in them. So to be able to be as flexible as we need our target setting mechanism to be for the projects that come in. So essentially, we are still just keeping the 2003 baseline, but it's a modeled baseline now rather than a database-based baseline.
Okay, great. Thanks, Pat. And I think we'll finish up with just one more question. Sorry, I just lost it for a second. Can you outline the mechanism by which you set the energy target? So there's a few different ways to describe that. On the one hand, in SB 2030, which is a very specific public sector program in Minnesota, there's a very regimented way that Pat went through on those 2 or 3 slides that the target is set based on a reduction beyond the 2003 benchmark baseline. In general, though, on other projects that we're doing, we are primarily using existing building energy data. Again, due to benchmarking ordinances, there's actually a lot of this data available. We keep our own database that we share with projects that we work with. Actually, we post it on 7th Wave's website as well. It's called EUI Analyzer if you want to look for that. But there are also federal databases, CBECs, local jurisdictions like states will often keep databases. There's no shortage of good data points, and we really feel that those real building performance data points make the best benchmarks. And then it's really up to the owner to set the target. Now, if you're a utility program and you want to gauge savings, you do need a more regimented approach, and we would have to develop that with a utility program to determine the amount of incentive that somebody were to get. So I'm guessing that was kind of implied by the question as well. How would you set that? If you were in a program context, how would you set that target? And I would still say that it's got to be based on actual building performance data. You'd likely use something like the median of recently constructed buildings of the same building type. And I would argue to try to keep it fairly simple. You don't want to get to the point where you're doing a big calibrated energy model in order to determine the outcome, because then you're kind of back to where we have been in the new construction world with the baseline to proposed savings comparison. There's a lot of power in this simple single target that everybody's chasing. So I'd like to keep it simple like that. So we're gonna stop there. We did have a few other questions. We'll try to answer those via email. Also, you see our email addresses here. Definitely feel free to shoot off a quick email to any of us or all of us right now if you've got more information or want some follow-up. And lastly, I just wanted to mention a couple of project resources. This is the CARD website. You can find more information about reports from past CARD projects, as well as webinars for other CARD projects. This is also where you would go to download the final report for our project, which again should be available in a few weeks. And if you want to watch this webinar again or download the slides, there's some handy links right there. With that, thanks a lot for participating. Before we leave, I just wanted to note there are a number of great CARD webinars coming up. On December 7th, Michael's Energy will discuss their project testing 2 ongoing commissioning approaches for outpatient medical clinics. On December 14th, the Center for Energy and Environment will conduct a webinar on their field study to determine increased efficiency from a moisture and heat transfer retrofit device in residential buildings. And on December 19th, GDS Associates will report on the results of their evaluation of an innovative liquid cooling technology in Minnesota data center. And finally, on January 4th, Apprise will discuss a study which sought to help the department and other stakeholders develop a better understanding of how low-income conservation improvement programs, SIPs, in Minnesota operate, and how we can make those low-income programs more effective. Again, announcements about upcoming webinars and other news related to SIPs can be found both on that website I just showed you, as well as the CIP newsletter. To sign up for the newsletter or receive email news, use the link on this slide there toward the bottom and go to the email sign-up page on the department's website. In the meantime, certainly feel free to contact Mary Sue Lobenstein. Her email address and her phone number are given on this slide, and she'd love to hear from you and can provide more information on how to sign up for upcoming webinars, or if you have questions, or if you just have feedback on the CARD program. Also let her know if you have any suggestions for improving these CARD webinars in the future to make them more relevant. Other than that, thank you so much for joining us today. We really enjoyed this project, and it was great to share it with all of you.